So hopefully you guys can all see my screen now. And like Anne said, for the next part, we're going to go through Inspire Motion. So within this part, we have 3 parts again. So we'll look at what is MBD. So for anyone who's never conducted a multi-body dynamic analysis before, we'll go through what that is. We'll then again have another software demo. And obviously we'll go through the benefits of looking at MBD and any questions and answers that you might have at the end. So MBD stands for multi-body dynamics. And why do we do it? So with multi-body dynamics, obviously, before you conduct your structural analysis or an optimization, it's all well and easy if you know exactly what the real life scenario is that you want to emulate. So if you know for a fact that you have a beam with a certain amount of mass added to the end of it, then you know exactly how you want to simulate that. Or say if you're trying to replicate physical test data, so if you're looking at an Instron test machine for tensile test coupons, you'll know exactly the rate at which it's being pulled apart at, and you know exactly how to set that up. But what happens when we actually have more than one part? So when we're looking at an assembly, we want to look at more than one part itself and how each of those parts are actually, moving in conjunction to one another. This is when we want to do a multi-body dynamic analysis. So it's understanding your part assembly mechanisms. So understanding how parts move relative to one another. And through doing that, you can also look at the motion characteristics. So just because your parts are connected together and the way in which they are connected would dictate, different parts be moving at different speeds, and they'd obviously experience different forces acting on them. You do it so that you can actually design for its intended use. So there's no point in designing something where it's not going to fit in with the rest of your assembly of parts. So you're designing it for the way it's going to be used. You can also find the generated loads on each component. So the way in which they're connected obviously would dictate how much force is acting on one part from the other. And obviously once you then find all these forces, you can then take it through for a structural analysis to then understand exactly what the stresses are that goes through it and how much it displaces. So if I can just show this small clip here. Just from the way it's moving, you can look at exactly how you can optimize it because you know the forces through it. You then take it through for final design and strength validation, where you can see the stresses that goes through your part. So you can see if your part has been designed to withstand its load case. So the workflow in itself, when we're looking at a structural analysis, we start off with the multi-body dynamics. So to understand how parts move relative to one another, you then take it through for a structural analysis. So based upon the way they move, how do they affect the stresses in your parts itself? Will it break during its use? And obviously if it doesn't break, and you know for a fact that you can make it lighter or you want to optimize it as well, you can conduct an optimization. So this takes us on to looking at the software itself. Jan, if you wouldn't mind.
Hello and welcome to looking at Inspire Motion. So throughout this session, obviously you'll come to terms with understanding, the software suite of Inspire, where it's not just limited to looking at structures or optimizations. You can also look at multi-body dynamics. So looking at Inspire Motion, where this encapsulates all the MBD side of the tools. Now you'll see within Inspire itself, it works from a left to right format, so where you can go from looking at geometry to then going through to structures and motion, you can see we work from a left to right format, and that's the same that can be applied to our ribbons as well. So you can see from left to right, you can open up your files, you measure your different parts, you can move them, translate them, rotate them, and then it goes through all of your different tools that you might want to use to set it up to actually solve for the final part. And you can see that straight from after conducting your MBD analysis, you can actually take it through for a structural analysis, and then you can take it through for an optimization as well. But that's something we'll come to slightly later on. So you'll probably know for a fact that within all of our software suite, we are CAD agnostic. And what that means is, we can read all of your CAD in its native CAD format. So as you can see here, these are all the different types of CAD that it can read in. You don't need to translate it to a certain file format, you can just bring it in as it is. But a really nice feature tool, which I'm going to show you, is that say if you have your part within a Windows, you can easily drag and drop them as well. So you can drag and drop it in, and from here you can see exactly how we have our part in this point here, and if we orientate it, you can see from angle upwards. So for any of you who don't really like the display currently, what I would recommend that is if you go into File Preferences, you can easily change your modeling space as well as the actual workspace itself. So if the theme of white is a bit too bright for you, feel free to change it to a slightly better gradient so that it's easier for your eyes. You can see that you can actually look at all of your different run controls, so your mouse controls as well, your run options to use, the number of cores that you might want to use. I'm just using 2 for now because the example that we go through today won't require anything more than that. And then obviously within the post-processing for the legend colors, you can change them all here as well. So for now, I'm just going to keep it as it is. What I also wanted to refer you to is that should you need to come across any sort of tutorials or help in the future, feel free to access the help page where you can look at the help page for the user guides. There'll be lots of other tutorials that you can use, and obviously you can look at what's new within the release that you're using. Just to also make you aware that within Inspire itself, we have in the bottom corner where you have your units. So what's really nice about this is that based upon what you already have, not only can you specify the units that you want to use, but it also acts as an internal unit converter. So anything that we have, whereby if it's in tons or kilograms, you can easily convert it so that you can understand it better. And say if you're receiving data from America, where they use a different file format, you can easily bring that data in, and then you can always convert it internally within this software here. So you no longer need to access Google to look for these converters. You also see that within your side, you should have a model tree and the property editor. For those of you who don't see it, the way to bring it up is that if you click F2 and F3 on your keyboards, they are the shortcuts to bringing up these browsers. So if you don't have a keyboard, then feel free to go into View and click on Model Browser and Property Editor, so that any part you click on, you can always look at the properties of that part in the Property Editor. So you can always rename it, etc. For those of you who can't see the mass, right click where it says Object, and where it says the mass, just make sure you tick on it, and we should be able to see the mass panel. And very quickly, if you click Calculate, you can see the mass that's associated to each of your parts. For those of you who realize, then you'll also see that each part by default is assigned steel. Your material properties in an MBD study wouldn't matter yet, so I wouldn't worry too much about that. So to begin with, obviously if we're looking at Inspire Motion, you probably already know for a fact that, previously when you do conduct an MBD study, it's a really nice way to understand the mechanisms and understanding, how your different parts move relative with one another and how they interact with one another. So MBD is great for looking at, suspension systems, calculating different hard points, and obviously it's just understanding how each of your mechanisms of parts interact with each other. So the forces that's generated on each other, how they connect up, and how they all move and assemble. So you'll see that within the Inspire Motion ribbon, obviously if we go through from left to right, what you can do with the measuring tool, you can easily measure from different features to features. Now you'll see within Inspire, you also have what we call the snap detection tool. It's very intelligent with its geometry feature recognition tool, in that if we want to measure the midpoint of a line, it tells you where it is, so you don't need to go through and calculate the full distance and then try halving it. Just by hovering over certain elements, you can find the center points of different parts, and you can see very quickly just how big that part is. And obviously if you don't want to see it anymore, you can just delete it off. The move tool, you can easily specify exactly what it is you're moving. If you were to click on a part, you can easily manipulate it in the Z axis or on a plane itself, where you can easily just drag and drop it. So feel free to use the manipulator tool. If you do need to look at translating your parts around and moving all around, then you can easily interact with it using this tool here. Now, to start off this exercise, what we're going to make sure is we're going to set up this motorcycle suspension part for an analysis. So what I wanted to show you is that within the Analyze Motion tool, where we have this fast forward button, that's actually the motion quick run button. So if we were to just click on it, you should be able to see your motorcycle part fly off into midair. Phew. And what that tells us is the fact that our gravity has been specified in the wrong direction. So to start off logically, obviously we go through the crawl, walk, run method. So we start off crawling, make it very simple, we then add complexity to it to then be able to run it. So just for sanity check, we need to make sure that our gravity is in the right direction, and you can see currently it's pointing in Z. Let's make it in negative Y. Now you'll see that we also have different parts here where we can ground it. So where you ground a part, it means it's not going to move relative anywhere else in the design space, relative to the design space. So that's what we call grounding. It's never going to move. We can set up some rigid groups. Now, rigid groups is a great way of simplifying, the amount of parts that you have within a study, because obviously you're going to have parts that will move relative to one another. So if we create 3 groups, now to create rigid groups it's really easy. Just click on rigid groups itself, and what we're going to do is select this part, and this part. We can name rigid group 1 and just click create. And you see that once it's in a rigid group, it will go transparent. We'll do the same again. You'll see within here, we actually have hidden away is another spacer down here. So click on that part and click on this piston as well. Click create, that's our second group done. And what we also want to do is make sure we have this link with this other internal spacer down here as well as another rigid group. So all in all, we have 3 rigid groups. Now, for anyone who doesn't know what their groups are, or if they've done it correctly or not, at the bottom of each button down here, you'll see a table icon. And through this, you can review exactly what your groups are. So if you need to go through and edit it again, you can always ungroup it and regroup them to create it again properly. And one of my favourite tools in here is the fact that on your mouse button to exit out of a tool, you can easily right click and swipe left to exit out of it. Or you can simply hit escape on your keyboard. Now once we've done this aspect, what we want to do is go through and look at joints. So joints is a really nice way of dictating exactly how your different parts should all be moving together. And you'll see that at the moment you click on joints, automatically it will do an auto search of the different joints you can implement on your parts based upon what you have displayed. So if we set it to all, it will go through and look at all of the different types of joints that it can put in for aligned holes, single holes, cylindrical pairs, etc. So if we start with aligned holes, you'll see that we have these 3 here, because obviously this is where the holes in our parts are aligned. And if you just click connect all, you'll see that it's put a pin through them, and that's exactly what we want, because we want these parts to be able to rotate around one another. Now if we do it again for single holes now, you'll see it's found these 2 single holes. Click connect all again, and because they're single holes, what's nice is that it will put a grounded pin through them. So those are the parts where your components are grounded, in that your whole motorcycle suspension part should no longer fly off anywhere else, as it's being held at these 2 single hole pins. For the rest of the other options that you also see within this ribbon, obviously you can use couplers if you want to set up a ratio between the rotation of certain parts together. You also have motors which you can attach to certain holes, surfaces or pins of your model, and obviously this then implements a rotational motion on your different parts. For our exercise, what we're going to do is actually attach an actuator. So actuators are effectively the same thing as a motor, but instead of it being rotational displacement or rotational motion, it's translational motion. So if you were to hover on the back of this spacer here, and you'll see the word CEN for center pop up. If we click on it, you'll see now there's a tick box. Click on it once again and you can see that you can attach an actuator to it. So at this point here, what we want to do is click on the double chevron and then use the manipulator tool. We want to rotate it around X for 60 degrees at this height. Within the property editor box, make sure you tick maintain coaxiality. Now all we need to do is right click, swipe left to bring back into this micro dialog box. So you'll see that within any of the tools, when you do something or when you click on, let's say, this part here, within the micro dialog box, this is where you can go through to actually implement the way in which you want to set something up. So for our actuator, we'll keep it to displacement. And where we see this table function here, so the profile function, if we click on it, we can actually dictate the motion in which we want to see. You'll see that we have a variation of different ones, such as like a step function, step doorstep, or ramp, etc. In this case here, what we're going to do is use table because we actually have tabulated data that we want to bring in to dictate the motion. So click on this open folder, and within open folder, what we're going to do is click on this actuator input data meters. So this is going to be in meters. So if that's in meters, make sure that your units here at first are in meters too. So if we bring in that file, so make sure we bring this in, and you'll see that we have all of the meters of displacement that we want to implement. And you'll see that the moment we convert it to millimeters, there you can see it does it in millimeters too. Okay, so once that's been dictated, what we're going to do now is close it, and we'll know for a fact that this actuator can move with that sort of displacement. And in order to test it out, what we can do is right click, swipe left, and just click play. And as you can see, because we haven't connected other stuff up properly, you can see that our actuator has been set up properly though. So for the next step, after we specified the actuator, that's done, we're going to now implement a spring. So within this spring here, we're going to connect it between the piston and the housing. So before we actually do it, make sure you click on this part, and if you hit H on your keyboard, you can hide it off. And obviously if you click on A, it brings all your parts back up. So just click on your part, click H to hide it. Now clicking on springs, what we want to do is make sure you have the center mark pop up for this surface here. And same again, if we hover into this surface here, so where we just kind of hover over this surface, we should be able to see the word center pop up. And as you can see, we're now connecting a spring damper, from the bottom to the top. We'll give it some stiffness values. So for K, we'll make it 12. So stiffness of 12, we'll give it a damping of 2. And we'll also give it a preload. So let's give it 550 within this preload, so you can see that because our arrows are pointing out, you can see that our spring is in tension. So once we've set all that up properly, right click, swipe left. Obviously if your parts itself in your future projects, if you need to implement contacts, you can easily specify that between different parts. If there's any sort of initial conditions you want to set, and always make sure that gravity is in the right direction. So if we bring everything back again, what we now find is that we can specify the time in which we want something to solve. So we can just specify 5 seconds. Output rate would be the amount of data you want per second, because obviously it's in hertz, so we can just keep it to 30 for now. Animate, you can see, obviously you can watch the animation, you can choose to do it while solving or when finished. I always like to keep it on while solving, so if I go wrong, I'll know immediately how wrong I am. And for the analysis type, we'll keep it transient, and just click run. So there, from here you can see exactly what's been dictated, and obviously any sort of issues that come about, we'll implement here. My issue here, so as you can see if we play this again, so my issue here obviously comes about because there hasn't been a connection between my piston and the actual housing itself. So what we're going to do is head back into joints, and I've realized that I have left off a cylindrical pairing. So what we're going to do is make sure you toggle onto cylindrical pairs, and it could be that within your options that it was probably ticked on auto search distance. Untick it and make it 2 and click find. From there, what you should be able to see is that it's found itself a cylindrical pair. So what that means is that the housing and the piston itself can only move cylindrically to one another, meaning it can only go in and out of that shaft location. So tick on it once, make sure we establish a cylindrical connection there. So now when we go back into quick run, we can now see it moving as we would expect it to. Make sure that your termination time is actually set to 2 seconds, because obviously 2 seconds was the amount of duration motion that we've put for our actuator. And as you can see, it now moves the way in which we expect it to. Now, a really nice tool in Inspire is the fact that for any of the post-processing, whilst your animation is being played, you can click on any of the parts and you see the data that comes up for it. So you can see the displacement of your parts, the velocity of them, as well as the acceleration. And obviously if you were to right click on it again, you can also export this data as a CSV file or as an image, or if you want to take it through to doing an analysis, you can then also export your loads on parts and your connected locations. So what I wanted to also show you was that if you clicked on a part itself, you get all this data. If you click on a joint, you then also get the forces, so you can see exactly how much force is exerted onto this part from the previous part as well that it's connected to. And then from the joints itself, you can then specify if you want to look at torques, if you want to look at the displacements of it. It's all listed here for you. And better yet, if I can click on the Force Explorer, with this Force Explorer tool, you'll be able to see the forces that are generated throughout. So currently we're just looking at the ones for springs. Now if we were to click on joint forces too, you can see all of the different forces that are generated and torques that are created as well from the joints. And obviously through here you can find out the worst case scenario for in any sort of time fraction where the maximum forces are coming out of it. So just know that you can go into Run, Force Explorer to access all of this detail. Now you personally don't actually need to take it through and then start, finding the location to see where you can, orient the force at a certain angle. By default, for any of your parts that you do, you can simply click on them, right click in the graph and click on Analyze Part. And what this does is that it takes all of the forces that it's found within the MBD analysis, and it can take it through for structural analysis to see exactly how the stresses will vary throughout the part during its time in motion. So you can do it for just the 5 peak loads per connection, so that's looking for your 5 worst case scenarios. Or what you could do instead is use all 60 time samples, and obviously you don't need to do the meshing yourself, you can just specify the size of the element that you want to use. You can look for a natural frequency too, if that's applicable to you. In speed and accuracy, just keep it to more accurate because this uses second order elements to mesh for structural analysis. And obviously with loads for your motion, I'm just going to use all 60 time samples, and once you've done that, just click Run. Now obviously I've already actually solved this previously before, so I don't need to run it again. I will bring up my other results so that you can see it's got the same motion as it goes about. This is just time slightly slower. If I made it slightly faster, like the other one, you'll see it's the exact same motion. But what's nice is that once it's taken itself through for the analysis, just simply clicking on this contour here, it brings up your results for you. And on the side, obviously, you can look at the displacement of the parts and obviously the stresses that this part will experience throughout that whole time in its load case. So if I also click on play, you can see how the stresses vary through it. Obviously the animation settings at the bottom are self-explanatory, so you can obviously click play, you can fast forward to the final frame or to the beginning frame as well. If you want to record your motion, just click on this record button here, and obviously any sort of animation settings you want to change, you can change them all within this options icon here. But just from that MBD analysis, now you can see exactly what the stresses are that your part will experience. And with this ISO slider here, you can slide it up to a certain value so that it will only show you the moments in the time frame when any of the relevant elements exceed that value of stress there. And obviously you can change your maximum and minimum values as well. So if you change that to 100, then you can see more areas that are affected. The same can be done within Inspire Motion, in that obviously you have your different callout functions to specify for the stress value at that time. You can look for your minimum maximum results as well. And these minimum maximum results will be specified for you. And obviously you have different display formats as well for your parts. You can look at it with the wireframe, so the original geometry before deformation, and obviously the worst case scenario, etc. As you know, after conducting any type of analysis, any type of structural analysis that we do, obviously we now know the stresses that go through it, the displacements that it also goes through as well. What's nice is that obviously we can then take it through for structural optimization as well. So if I head back into my previous model, where obviously we could see, if we were to just click on any of these parts, you can right click and do analyze, but you'll see that underneath the optimize option has been grayed out. So if you want to take it through for an optimization, you can simply go to where the part is in itself, and obviously where it says design space, if we want to tick it, you'll see that that turns the part itself from a grey colour to a burgundy maroon colour, and what that means is we're telling the optimizer itself, the solver, you know, that to implement the optimization on this part, and they can take away any material that they like from it. So if we were to right click on this graph here, you can see that we can now optimize part. It will take you through to the optimization run panel, so it's quite similar to the analysis one, but obviously instead you're doing an optimization and you're given other options for it as well. So the type of optimization that you can do, you can conduct a topology or topography or gauge optimization on it. For this exercise we'll do the topology one. We want to maximize the stiffness of it as well, whilst using only 30% of the total design space volume. So we're going to tell the optimizer to take 70% of the material out of it. If you have any sort of frequency constraints, so if you know for a fact this is an assembly of parts and there's certain frequencies that you don't want it to resonate with, make sure you specify them here. You can specify any thickness constraints as well, so any sort of manufacturing tolerances where if you know for a fact you can't have beams thinner than a certain diameter, specify them here as well. An optimization, we recommend using the faster meshing algorithm, so don't use second order elements, use first order ones, and either you can tell it to optimize from using all 60 time samples or the worst case scenarios, up to you. And obviously from here just click run and it will run in the background for you. Now I already have one that ran, so it only takes around 20 minutes to run, but I've had one that's already ran. So you can see it's the same setup again, and in this case once it's finished running, just by clicking on the truss button at the top here, you can see that this now gives you a new design. So obviously if you head back into structure, you can specify other manufacturing constraints to it as well if you want to specify symmetry or draw direction, etc. But the Inspire structural analysis video should take you through that instead. So if I just head back into motion, and where we see optimization itself, you have a topology slider, so it tells you exactly, you know, the first areas where you really don't need material within. So it takes away all your redundant material, and you can see exactly what kind of shape it recommends you to conduct. And straight through here, what we could do is implement, let's say, a cross section, and within this cross section itself, we can drag it so that we can see exactly what our optimized shape looks like. So you can see it's quite a hollow shape, and then it's down to you as an engineer to interpret how it is that you want to redesign this part. You can make it with solid beams, it doesn't have to be hollow, it just needs to be lighter than what it previously was, and you can redesign your part. So previously it was a thick solid like this bracket here, and then obviously it then tells you to hollow some of the areas out as well. And as you can see from the actual optimization itself, you can very quickly fit polynubs to it to then actually generate geometry out of it, or you can click to analyze it to analyze exactly the stresses that goes through this optimized part during the MBD run to see exactly if all of these elements still are within your stress targets as well. So this is effectively just looking at the MBD workflow in a nutshell. It takes you from, you know, setting up from your MBD analysis, understanding the loads that you get from your mechanisms. So from here, just seeing all the different loads that get generated out of it as well, and seeing exactly, you know, how it is that our parts interact with one another, through to then taking it through for an analysis, so you can see exactly all of the different parts and the stresses that it goes through, And if we were to take it through to the next part again, then you can see exactly how you can then optimize it as well with respect to multi-body dynamics. So thank you very much for listening, and I hope you enjoy using Inspire Motion. Thank you.
Okay, so hopefully that gave you a really good overview as to, Inspire Motion and multi-body dynamic analysis itself. Just remember that multi-body dynamics isn't just limited off to vehicles as well. You can use it in a plethora of other sort of applications also. As you can see from the examples at the side here, obviously you can start looking at manufacturing, so looking at conveyor belt simulations. You can look at pickups, so you can see that there's also tracers, where you can trace the motion within Inspire. You can look at biomechanics, so if you're looking at any sort of biomedical devices. You can optimize for different excavators as well, so looking at an optimized design for that. And obviously for domestic goods, you can look at washing machine loads. So just remember you're not tied to just one discipline. So before you design anything, you can always consider using multi-body dynamics. It's simulation-driven design. So that means you get a full comprehension of your designs itself, and you're designing it to be as efficient as possible from the very beginning. It's quick and efficient. You saw how easy that GUI was and how user intuitive it is. So that means you get quick and efficient MBD analysis done. It uses motion solve in the background. So even though it's just as fast and easy, it doesn't mean it's not accurate, because in the background of the solver, you're using our full-blown accurate multi-body dynamic solver called Motion Solve. And if you did want to take it through for a more complex analysis where you start looking at flex bodies, you can easily export this deck out to then go into motion view with it. And what's really nice is that you can conduct an optimization derived from an MBD analysis all in one GUI for you. So thank you very much for listening. I'll be happy to take any questions and answers that you may have now. So Inspire Motion is great if you want to start up from the very beginning, where you're just looking at assembly of parts. However, I know it's quite automotive focused with our participants today. So say if you already have your vehicle and you want to take it through for a KNC analysis, you can use the actual wizard in itself to set it up. I mean, if we have enough time, I can do a live demo of it now, if we like. Let me launch up Motion View then.
If you feel comfortable, of course.
Yeah, definitely. Yeah. Let's do it.
All right.
Sure, hopefully you guys can see my Motion Solve screen coming in now.
Yeah, we can see it.
Brilliant. Okay, so obviously with Motion View, this is part of our HyperWorks suite. Now, in terms of the HyperWorks suite, this is where you can access HyperMesh, OptiStruct, you can use Radios, etc. Now, with multi-body dynamics in HyperWorks, you use Motion View and Motion Solve. So you can see the GUI itself is quite different. Now, where we're looking at vehicle tools, you can easily go into your preferences files. And what we can load up would be the vehicle dynamic tools, so MBD. And if we were to load it in, what then this gives you access to would be the different libraries that you have. So with the vehicle tools itself, you can then start looking at the model assembly wizard. So you can start looking at putting together a full vehicle build. So you can look at just looking at the front end of the vehicle or rear end of the vehicle, or you can also incorporate a driver. So for instance, say if I click on the front end of the vehicle here, you can then specify a different driveline configuration for it. So say if we did a front wheel drive, you then have the different primary systems that you can attach to it. So if you know how exactly you'll be designing your car and the different systems you have attached to it, you can then specify them all here. So with the front suspension, you can look at putting in the McPherson suspension or front SLA suspension or multi-link one. I can just keep it to that one for now. Any type of steering linkages that you want to do, you can also specify. And obviously any powertrain that you want to incorporate, you can bring it in. With the steering subsystems as well, you can specify exactly the boost, so if you want to use a rack ping steering, etc. Any sort of springs, dampers, and stabilizers as well. You can look at if you're just using a front strut with inline joints or cylindrical joints, and you can specify it through here. And what you're doing effectively is just building up the vehicle that you're doing it. So if you know exactly how you'll be designing your Formula Student cars, you can then specify what you're looking for. So any sort of jounce bumpers or rebound bumpers you can incorporate in as well, the driveline systems. And once it's finished, you can click Finish. And you can see very quickly it's put together the model that you wanted for it. So you can see it comes with tires, you have your different parts for the suspensions. And obviously this is just the most basic thing. So if you know the mass of your own suspension parts, etc., you can edit them all here so that you can understand fully the characteristics of your model as well. Now, this doesn't mean to say that you can't easily replace these with your own CAD data as well. So if you have all of these drawn up, you can simply go and replace them in graphics. So that, say if you have your own lower control arm, you can then look at the graphics it's attached to, and then you can bring in your own parts in that way. So if you want to look for finding the hard point locations, if you want to optimize it for that, you can do it here as well. And what's nice is that within Analysis, where you have your task wizard, this is where you can actually attach different analysis types to it. So if you want to look at conducting a kinematics and compliance analysis, or if you want to look at a static ride, if you're looking at a steering analysis, you can simply click on Next, Finish. And what this intelligent wizard does is it just maps this analysis to your actual setup already, so you don't need to go through and do it yourself. You can then obviously specify your different tire static loaded radius, so you can adjust this specifically to your vehicles. So any vehicle parameters, you can change them all here. And obviously you can specify the parameters that you want it to follow and finish. And once you have all this, obviously you can then edit the actual analysis in itself. But then what's great is that, say if I was to run it right now, so if I were to just save it in this folder, I'll just call this demo. Now you'll see that you can just keep it to the analysis that you already have. And if you were to run it, just in a few seconds, you can see it going through and solving it all very quickly. So for those of you who've never used it before, it is very easy to use as well. And pretty much once it's done, just give it a few more seconds. You can also see that at the end of this, once it's done, it also has a report wizard for you as well. So once we have these message logs, I wouldn't worry too much about the message logs. If you have these and an error comes up, this is the best way to decode and see what your error is. But if you're not getting any errors, then that's great. And just know that once it's pretty much done, you then get to look at your results. So in this case, what we can do is click on Animate. And you can see that it brings your results on the other side. So that if you were now to click play, you can see that it's conducting a kinematics and compliance analysis on the front end of your vehicle. So it goes through and it looks at, how it is that your vehicle can respond to all of the different excitation loads you apply to it, the steering analysis, how they turn and how they bounce up and down. And like I mentioned before, in the tools, you have, which area was it? Analysis, sorry, you can view reports. And based upon those KNC analysis, you also get a report generated from it. So if we were to click OK, it brings up all of the useful information that you need. So if you want to look at camber or ride height, etc., this then has all of the graphs plotted for you. And obviously, you as engineers, it's down to you to understand exactly what this means in your data and what different designs, parameters that you can vary in order to achieve the best type of design for you. So obviously this tells you everything you need to know, so your different lateral forces against camber, toe, and the wheel center. And you can see it gives you everything you need. And at the very end, it will also take you through to look at the animation. And you also get all of your data in a tabulated form. So this is the beauty of the reports. All of the post-processing is pretty much done for you. Now, this isn't to say that you can't actually do this with a full vehicle. So let's just say that I implement a new page as well. So at the end of here, if I start a new page, what I can simply do is let me toggle this to motion view again. And within project, we can do the same thing. So say if I go to model, assembly wizard, this time you can actually start looking at, let's do a full vehicle with driver. That would be quite fun. Let's do a front wheel drive. We'll just keep everything as default. Just know that you can also implement any sort of disc brakes that you want, a driver, and if you were to click finish. If you're looking at full vehicle, what's nice is that you can look at single lane changes, double lane changes. You can also create your own roads. So if you want to make your vehicle doing donuts, you can do that also. So just very easily, you can look at the analysis that you attach to it. So say if you want to specify it to do a J-turn or let's say a double lane change, you can specify it for this. Just click OK. And just like it did previously before, you can now see that you have a road for where it will do a double lane change. You can also edit this event, so if you wanted your lane change to be a little bit more dramatic, you can always change your length sections and your parameters in this area here. And as you can see, from your different analysis that you set to it, you can then also look at exactly how the results that you want to get from it. So the result graph and the reporting template, etc. So if we have these, simply let's do the same thing again. Let's save it in here. So let's do car demo. You'll see I'm quite original with my naming convention. And then very simply just click run. And same again, this does everything for you. So if this is the event that you want with the right vehicle you need, you can easily personalize that vehicle to being your design by just changing the masses of certain components, suspension parts, etc. And very quickly you can understand how your design works and how you can go about changing certain parameters to better the design of it as well. So whilst that's solving in the background, let's have that solving. Just know that it's not just limited to cars. If you want to start looking at scooters, you can. So within models, if we set the wizard paths, you're not just tied down to a car or small truck. You can look at a heavy truck, two-wheelers. And obviously, if I did two-wheelers, this just means that when I create my assembly, you can look at a full motorcycle with driver, and you can do, let's say, rider detailed, and you can specify the frame, the type of bike that you have there, so your motorbike, the front suspension, the rear suspension, powertrain, etc. So if I just keep everything as default for now, you'll see what's very nice is that you now get to see a rider on top of a motorbike. So give it 1 second just for it to load. Now hopefully my previous one, so as you can see here we have an occupant on top of a bike, and you can see the occupant, because we specified a rider detailed, you can see it in its humanoid form. And we can see from our previous one, it's already solved. So if I were to click on animate from here, if we were to click play, you can see this car driving down and exactly how your car will react itself when going through these different changes. So, and obviously you can understand the camber of your cars, the camber of the wheels, the steering angle as well, and the way through it. Doesn't look like it's going very fast, but obviously we can make it look slightly bit more exciting in this manner. And obviously, where we just look through into it, you can see exactly how your part behaves, the car itself. So say if we were to hide off this body kit, if I was to speed it down just a little bit, you can see how all of the internal systems are working throughout the driving of it. Speed it down a little bit more. There we go. And obviously you don't have to use these analysis that's already been set up. You can very simply create your own roads, and you can even create the track that you want to use. So you're not just limited down to just cars or small vehicles, you can also do bikes and heavy trucks. And you can see the same can be done for analysis in the bike. You can specify it to do a brake and turn, a J-turn, whatever you need. So if I did also run this, let's try running this as well. A bike J-turn. So this is what we meant by if you want to, take your mechanisms and your multi-body dynamics through for more advanced analysis, then use motion view. But if you're just looking at how your different parts move with respect to one another, then you can use Inspire Motion. If you want to start looking at kinematics and compliance analysis, I would always recommend to start straight from motion view. If we were to just animate one last animation, let's make sure that I'm in the right frame. So this one's slightly harder to see because obviously we don't know where that road is. Well, we can see exactly how it's going to react in its J-turn. And the same like we said before, you always have the right reports. So you can have a view report to visualize all of the useful information that you need out of your analysis. There we go. Any questions from anyone so far?